let's continue talking about the chain rule. And we can talk about the chain rule, and we can. I cannot give you every example of every chain rule problem that you ever see. There's an infinite number of ways these problems can be represented. So, as such, you have it comes down to practicing them, learning the skills. You'll see a variety of problems throughout the course. You'll see more problems that require chain rule in tomorrow's lesson, and Friday's lesson, and Monday's lesson. You'll see them apply to different types of functions, but we have to do and understand that. So we have application methods. And the application methods we've learned so far are the product, the quotient, and the chain rules. So these are application methods for derivatives. And then you have function methods. And so far, we only have power functions. Now, tomorrow we'll talk about trig, then we'll get into exponentials and logarithmic, but those are other functions. But right now, the only function in terms of analytical-wise is a power function, which is the bringing down the number, power number, and so forth. So that's good. The good news is that the only function that you have to be dealing with in reality is a power function or a function written in function notation. So like those end problems examples I gave you yesterday, or the ones you saw on the set 3 where you have f of x and so forth. But today we're gonna be really doing a lot more examples. Let's do more examples of combining. So let's take this first example. Of course, we want to find f prime of x, where f of x is equal to, parentheses, 3x plus 2 over 5x minus 4 to the 5th power. Now, because I anticipate I don't know how much it's going to be non-calculator, and I don't think it's worth a lot of our effort. We can focus it on later on. There's a lot to be said about simplifying. There's a lot to be said about manipulating functions, algebraic steps in terms of how to clean things up, how to rewrite them. We want to do that. It'll help us sometimes to make problems more efficient. It'll help us identify problems in multiple choice form. That can happen, but we don't really want to worry too much about that. All right, so we have this right here. We have to identify what type of functions these are, what type of function we're dealing with, what is our primary functions, and then it breaks down into that. So what type of function am I looking at here? What type of function am I dealing with here?
Is it quotient?
So there is a quotient. Well, what is the big picture function? So there is a quotient function inside here. And what is the big picture function? What are we learning about? What type of function?
Power function.
So there's a power.
Chain.
What is it?
Chain.
There's a chain, which we call a composition. A chain. So there's a chain rule. The biggest thing is that this is a composition function. There's a function inside of another function. How do you know that? Because you see x's surrounded by parentheses. That's pretty much your biggest giveaway. 9 times out of 10, you'll see x's, and then it'll be some parentheses with something outside that parentheses attached. That is the biggest sign that you're dealing with a composition function, which means it's chain. But in doing this function, the mommy, you got to think about mommy and baby, right? And so the mommy function, the outside function, is this is the outside, the mommy, and the inside, which is the baby. So you have to take the steps as we've done, and so we work from the way I teach it is I teach it from the outside in, outside in. Now, some teachers, some texts will teach it inside out. I've found that overall, you know, it works better for some people to go inside out. Some people do better outside in. In the end, you have to take a stance in terms of how you're going to teach it. And I feel that the most effective way for my students has always been the outside in method. I've tried the other ones in, and I've have lesser success overall. But some students do find success on the inside out, which means that we're going to, what are you going to attack in terms of derivative? Well, we're going to work on the outside and then work on the inside. So working our way from the outside, now there's no need to rewrite this function. It is already calculus friendly. How do I start my derivative? Let's take this derivative. The first step in this derivative, there should be nothing that should be, after doing the homework, if you were able to do the homework last night, the first step is a chain rule, power chain rule. It should be mistake-free right now. Everybody should be able to have to do this if you did the homework. There are some harder parts, but right now we're just focusing on the chain rule. We're working from the outside, and then we'll talk about the inside. Bring the 5 in front. Perfect. Bring the 5 in front, and then what? So I need a little bit more detail.
No, only 3x. Well, only 3.
No.
Only it's not 3 over.
No. That's it. So that's what I said was the biggest mistake that people would make. You have to leave the baby.
Do we keep it the same?
You keep it the same. You copy it down exactly as what you see. That's why I was asking for more. And when I asked for more, all of a sudden you started doing something that was wrong. Got to be careful about that. It stays the same. You see the baby, you see the inside stays in your answer.
But the power is changing.
Okay.
That's 4.
The power of 4. Good. Now that is the chain rule part right there. So that is the basic chain rule part. I can't have you make any mistakes in regards to trying to take care of anything on the inside on your first steps. That's the quickest way to failure for differentiation, because when we talk about chain rule is where you try to do things to the inside while it's still inside. It stays as it is. It was 3x plus 2, and so we see a 3x plus 2 into my answer. You cannot make a mistake there. Am I done?
No.
Okay, so what do I do next? And be very specific.
I think we need change.
Okay,
We need change.
okay. So how do we chain though? What does that mean?
So, when you use the equation and change it, another form.
We're not changing anything. No. So
when you change the x.
So sometimes what can happen, what can be helpful for you to do when doing these problems is to write it as times 3x plus 2 over 5x minus 4 prime. So you don't have to write it with this notation right here, but it sometimes can be something that can help you organize your thoughts. Because what we really have to do is a sub problem here, and we have to find what is 3x plus 2 over 5x minus 4 prime. What is the derivative of this? And so what is the how do we take the derivative of 3x plus 2 over 5x minus 4? This goes to the next step in identifying the problem. Now we have a new problem. We have to focus in on this part. So what method, what are we going to use to differentiate this? We're over here. How are we going to differentiate this? What do we use? No. How do we differentiate this? If I only gave you this, if I gave you this as a problem, and you ignore all this, and let's say I only gave you this as your problem, you're telling me you don't know what to do?
I think when you multiply 3 plus that power.
No.
So
There are a lot of, remember that there's two main things here. I hear and I see a lot of private chats. A lot of people are just trying to take the derivative of the top over the derivative of the bottom. And what I noted inside last Friday's lesson, that is the biggest mistake individuals make that we cannot make. This is quotient rule. This is u prime v minus v prime u over v squared, where I have my u and I have my v. So my answer to this problem is, of this subproblem, would be the derivative of the top, u prime, which is 3, times v, 5x minus 4, minus u prime, or v prime, which is 5, times u, which is 3x plus 2. The derivative of the top times the bottom, minus the derivative of the bottom times the front, all over the bottom squared. That's my derivative. It's the quotient rule. You cannot get the quotient rule incorrectly. You cannot do the product rule incorrectly. The quickest way to a zero is trying to just take the derivatives of each of them by itself. Don't expect partial credit for doing something like that, because that's a big no-no. If you're not applying the quotient rule, and if you apply the quotient rule wrong, you forgot the minus, or that could give you partial, because it's still wrong. Or if you flip the u primes and v's, your answer is wrong, but at least I can see that you're trying to apply the correct rule. Oh, and now all you got to do is you got to just replace this with there. So some of you can probably do this in a lot more quicker one step. So f prime of x is 5 times 3x plus 2 over 5x minus 4 to the 4th power times parentheses 3, or bracket, however you want to do it, 3, 5x minus 4 minus 5, 3x plus 2, all of that over 5x minus 4 squared. And that is my derivative. Now, if you want to take it a step further, if you're trying to get a 5 on the AP exam, if you're trying to get a perfect score on the AP exam, we can clean this up, but it's not a priority. A little star next to it. In cleaning it up, I would get 5 times 3x plus 2 to the 4th power times, what is that, 15x minus 12 minus 15x minus 6 all over 5x minus 4 to the 3rd power, to the 7th power, well, to the 6th power, sorry, which gives me 3x plus 2 to the 4th times negative 18 over 5x minus 4 to the 6th power, which gives me negative 90, 3x plus 2 to the 4th power over 5x minus 4 to the 6th power. Now, I would be very happy if you can all get to that part. If you want to get a 5 on the AP exam, you need to do that. If you want to pass the AP exam, you got to be able to differentiate this, all right? You got to be able to differentiate this on your own. So we have to apply the chain rule. Oh, and doing the chain rule, I have to take the derivative of this inside. Okay, well, this inside's a quotient, so now I have to do a quotient rule. Now, I'm perfectly happy for us if we get this derivative, and I believe you can get a 4 on the AP exam if what I blocked is what you have, and you write it just like that. And you know what? For us and with conic and for delta math and everything, that's going to be most of what we need the majority of the time. But if there's a multiple choice question and you have to identify, you have to recognize that that's top part, and sometimes it doesn't mean that you even have to do the algebra manipulation. Typically, you can say, oh, well, this denominator with this gives me to the 4th power, plus this 2 is going to give me to the 6th power. So I know the denominator is going to be to the 6th power. If you look at all the multiple choice options, there's only one choice that's going to have it to the 6th power, and there you have your answer. That will get you a 5 as well. That test, so you have to do 2 things to really get a 5 on the exam. One of 2 things. Either you're really good at your algebra manipulation, and you have really good algebra skills, and you can get to here. Or you have really good test taking skills, such that after you've done this correctly, you are able to recognize that these are the same thing. One or the other. And I'm saying that you can still get a 4 if you can't do this part or do either of those ones, but that's also if you're mistake free. All right. Let's do another example. I'm running out of time already. Probably shouldn't take that long. F of x equals x cubed times x to the 4th minus 2 to the 5th. Okay? When I look at this problem, what is the first thing I have to see in terms of the main purpose of this function? And of course, it's the same thing, find f prime of x. What is this problem at its forefront? And like again, there's different levels. This other one was a chain to a quotient. What is this? It was the previous one was a chain rule that also had a quotient built in. This is a product rule for perfect. This is a product rule that also has a chain rule in it. All right. And like I said, hopefully you feel comfortable enough. Now in my notes, like I said, I'll take a little bit extra step. So this is my U and this is my V. And the problem is that my V requires chain rule. But it's not a hard chain rule. Bring the power in front and so forth. As long as you're organized. So f prime of x equals what? Now product rule is u prime v plus v prime u. So what is f prime of x? The longer you guys take to participate, to respond, the less I'm going to be able to do.
Down 3x squared.
3x squared. I like to put it in brackets. Good. Times?
4x.
Nope.
Oh,
We cannot take the derivative times the derivative.
Sorry, so it's not put it the same now. The same state.
What?
X3.
No. See, no. That's why when I need to know what you're trying to say is the same.
So confusing.
Nothing to confuse here.
Will you just bring the x to the power 4 minus 2 to the power 5 down?
Yes. Here we go. X to the 4th minus 2 all to the 5th power. Bring it all down. Copy down v. You could also say just v. Copy v. All right, so it's 3x squared times v, because I've already identified what v was, plus, now I got to take a derivative again.
Would it be 5x to the
3? Parentheses.
Oh, sorry. Parentheses and then 4x to the 3rd?
No. So this comes back down to what we have to do in terms of, this is v prime. And ideally you can do v prime in your head. And you can do it, and you can let it flow. You get in a state of flow. But if not, then I have to do v prime on its side, where I'm going to only look at v right here and go, oh, v prime therefore is 5. Copy what's inside, x to the 4th minus 2 to the 4th power times the derivative of the inside, which would be 4x cubed. Organization can sometimes mean the difference between getting our answer right and wrong. And with these types of things, what happens in calculus is that there's no, you're just close. It can't be that way. And the only way you're going to do that is by practicing and making mistakes. Making mistakes are good. Got to learn from them. That's how calculus works. X to the 4th minus 2 to the 4th power times 4x cubed times all that times
would it be I was gonna say 4th, but I don't think it is.
Know your formula. All we're missing is this.
Oh, x times x to the power 3?
Yeah, that's it. Boom. X cubed. X to the power of 3. U prime v. Here's my u prime times v plus v prime, that big old ugly thing for v prime, times u. And that is my answer. That's good enough for us. Of course, if you want to clean it up, you don't have to. But I think it's important if you really want to get that full grade and get good algebra practice. In other words, there's nobody in this entire course who can't do more, who can't improve, who can't practice. If you're a person that fails, and there's very few of you, if any, and it'd be very impressive if you feel you already got this. Very impressive. And it takes time and practice. But even if you feel comfortable doing everything we've done, you can still do more. And that's cleaning this up, which I know we will still all need practice. This is 3x squared, x to the 4th minus 2 to the 5th power. And I don't have a lot of time to be able just to do step by step, so I'm just going to kind of run through. Times 20, x to the 6th times x to the 4 minus 2 to the 4th power, which is x squared times x to the 4th minus 2 to the 4th power times 3 x to the 4th minus 2 plus 20 x to the 4th, which is x squared x to the 4th minus 2 to the 4th power times 23 x to the 4th minus 6. Now, I went through that, and you're probably looking at that like, whoa, what did he do? I do not want you to be worried about that part. That is not a major focus of our part. 90% of what we want to get done is literally this, that purple part. That's 90% of what we want. That's 90% of what we need to get a 4 on this AP exam. Now, you want a 5, you're going to have to take extra parts. And that first, but you can't even worry about this part until you've mastered how to get to this, all right? So I put a little star there. I want it there so that you have at least it for a reference, but it's not our major priority. Now I could also ask you, might ask you for, find f prime of 2, and then therefore you have to plug 2 into the derivative. You can easily plug 2 into here, or plug 2 into here if you want to find f prime of 2. You can easily, you don't have this version or this version, it doesn't matter. I'd probably just use that version because I don't have to make mistakes trying to clean it up. Same thing with tangent lines, all works out the same way. When I throw those problems in there, that's just an added review. First, focus on the derivative. That's the forefront of the homework problem. Finding the derivative function. That's the heart of it. When I throw things in like finding f prime of 2, that's a second step. So I want you to focus on that f prime of x, master that, and then get that f prime of 2. Plug in 2. Then if I say tangent line, that means I'm testing you on finding the derivative, finding f prime of 2, and then using the tangent line equation. So there's levels to this, as they say. Multiple chain rule. I know you're probably like, wait a minute. I'm still trying to learn the chain rule, and you're throwing at me now the multiple chain rule? Don't worry. It's all about organization. This idea here is that the baby has a baby. Don't worry, these derivatives take a good, solid 18, 24 years to take. The baby, and then we wait a long time, and then the baby has another baby. So the idea here is that I want to take the derivative of f of g of h of x. A function inside of a function that's inside of a function. We're going to work our way outside in. So the derivative is f prime of, we keep everything else inside, g of h of x times, now we go inside one step, which is g, so g prime of, I keep everything inside as is, don't differentiate, times the derivative of what's inside, h prime of x. I try to keep, and I took away off problems that have really complicated babies, like multiple chain rule type parts. I tried to stay away from doing those too much. But let me give you a quick example. We have 6 minutes. We're going to use all 6 minutes. Y equals bracket x plus parentheses x squared minus 5 to the third power, close bracket, to the fourth power. Find dy dx. What is the heart of this problem? It's a what type of problem? I'm not going to be able to get to the next example if you guys don't speak up.
Chain rule?
Chain rule. So I have the chain rule. But within my chain rule, I have two babies. I have x, and I have x. I have this x squared minus 5 to the third. But within that chain rule, I have that baby on the second piece has a baby. So this is like this mommy has twins, and then one of those twins ends up having a baby. That's the idea of it in terms of the analogy of it. So when I want to find a derivative, and I don't have a lot of time in terms of going over this much more, those of you, and here's my advice to you. Here's my big, and this is as blunt as I can be. If you're not getting these answers right, and you're not attending tutoring sessions, and you haven't signed up for tutoring or going, in which there's sessions daily, that's on you. There's no more. Now, if you are doing those and you are still struggling, okay, that's a good thing, but you're doing what you need to do in calculus. But if you are struggling with doing any of the homework problems tonight, with all of the homework tonight, and if you're not attending study and tutoring, there's nothing I can do for you as a calculus teacher. That's the reality. If you're not coming to office hours and trying to work with me during the problems, if you're not setting up those tutoring sessions and taking advantage of it, I can't. And you're setting yourself up for failure in the long term. So I can't. You got to push. You got to push. So the 4 comes all the way in front. I keep the baby exactly as it is inside. X plus parentheses x squared minus 5 close parentheses cubed. I subtract the power by 3 times. I subtract the power by 1. That gives me 3. Times the derivative of the inside, which is 1 plus 3 parentheses. I keep everything exactly as it is on the inside. X squared minus 5. Close parentheses to the second power. Now, here's the biggest mistake people make. A lot of people do this part perfectly well, but then they make one last step. Times 2x, and the 2x is only attached to the 3 parentheses x squared minus 5 times 2. And then close my bracket. Now, I only have 2 minutes. I'm not going to be able to do a full example for the last one. And I kind of did it already yesterday. And you kind of already did it in your problems from on set 3 last night in your Delta Math. So if you did your Delta Math, as you should have, and for attending tutoring, I know you spent a lot of time on that. We've already done table problems, but I do want to note that there are going to be table problems where you're going to have to find h prime of a, which means you're going to be given some type of table with values with f prime, g prime, and x, like that. And you're going to be given some function. And so that function, for example, i.e. h of x equals f of g of 2 minus x. Find h prime of 4. We get a problem like that. All right, well, following the steps, this is a multiple chain rule. H prime of x, in this problem, I want to just show you at least an example of what steps would look like. F prime of, everything stays inside. G of 2 minus x. times g, the derivative of what's inside, which is g prime of everything stays inside, times -1. And then finally, when you're trying to find h prime of 4, h prime of 4 would be f prime of g of -2 times g prime of -2 times -1. And then when you look at the table, you're going to have to look up into your table g of -2s and g prime of -2s and so forth, and then plug those back in. So take the time, take the reality. If you have not been going to tutoring, sign up. There's open tutoring. Basically, Dr. Erica said it. I sent out the link. I posted the link on Google Classroom on the stream. So if you have not yet signed up, and you know, please do register. But if you just want to show up at 2 o'clock and just get right into the tutoring, take advantage of it. You really need to break this down. There's no ifs, ands, or buts about it. Calculus takes a lot of practice. Calculus takes a lot of mistakes, which is good, but you have to put in the time for it. It is the hardest course in high school for a reason, not because I'm the teacher, but because it is a course that it just requires you to hammer down and practice and practice and practice, and understanding and getting through things, that when things are tough, you don't just go off and quit or don't seek any help. Colleges know that if you've gone through calculus, you know how to seek help, you know how to work with others, you are brilliant, and you can do anything and be successful in colleges. And that's why they're so, AP Calculus looks so amazing on your transcript as a result. I know I'm a little 2 minutes over. I know you need to get to, and I need to get to our C block as well. Take care. Hopefully I'll see some of you at office hours.